Hey everyone, it's Eugene here. Just over a week ago, we had our very first Recon-3D training class. And as part of the class, we have a section which deals with the accuracy of Recon-3D and the iPhone LiDAR sensor. Now, there's different ways that you can test for accuracy with point measurements or doing something like a cloud-to-cloud comparison. But I was very fortunate in that one of the participants, Barbera, was able to present some data and validation testing that he did himself. So we want to be able to get this kind of information out there. It does no good if it's sitting on somebody's hard drive. So in his own words, I did crop the video just to certain sections and left out some of the question and answer stuff. But this is the core of what he had to say, and I'll just get right to it. So Guy, yeah, thanks so much for sharing, and I'll leave it with you for a couple minutes.
Yeah, thanks for the opportunity to share this stuff. What I wanted to do, obviously, was do my own validation study. We see Eugene's stuff, and I trust what he does. He does great work, but at some point, I intend to be presenting this stuff in court, and I want to be able to say, yep, I've done the validation studies. I know it's within X, X percent, X millimeters. And I also wanted to do, Eugene's done kind of small vehicles. I wanted to do a larger vehicle. And I wanted to do one that would be more challenging because it's not black, but it is a dark gray. I got it on a kind of semi-cloudy day, so the amount of sunshine varied. I made it easy from the standpoint of I put it in a decent sized parking lot with nothing else around it, so I could get around it. I also wanted to do it in a number of scans because I knew I wouldn't. I saw somebody asking a question: how are you going to do a scan if you got to adjust your monopod and all that kind of stuff? So I did it multiple scans. I did a total of 4, and I did a couple of loops down low, a couple of loops in the middle. I did one up higher with the monopod from the ground. And then I actually got in the bed and I tried to do the roof and the hood, some of which worked out, some of which didn't, just so you get an idea of the setup here. I also put down, I have these ground control point targets that we use when we fly the drone. I wanted to have something that I call fiducials that I could measure in various ways: scanner, GPS survey equipment, tape measure that I could then compare to later on to get some idea of accuracy, not just on the vehicle, but on other things that I could document. So that's what the setup looked like. Let me see. Just so that you get an idea of the scan deals. I won't go through all this. You can go back and watch the video if you want to. The one thing that I did, I knew I was going to be doing multiple scans. And I try to do it the way I do the Faro is I tend to use a lower resolution and try to do more scans with my Faro. And I try to do the same thing with the Recon-3D. I used an 8 millimeter point density. In hindsight, maybe I should have used a little bit higher, probably would have picked up those ground control targets a little bit better because they're kind of glossy surface. And I didn't get a lot of return on those. You probably saw I used the April targets, the April tags, and that worked out really well. I measured the center-to-center distance with a tape measure, and I input that on all 4 scans. And I ended up doing no scaling and cloud compare, and everything seemed to work out very well. There's the scan times I used. So I had a total of just over 6 minutes. I processed in the cloud. You can see the Faro scans. I ended up with a 5.5 minute per scan. I did 7 of them. 6 around the vehicle from the ground, and then put the tripod in the bed of the pickup to get the roof processed and registered in Faro, and exported a E57 file that I was then be able to bring into Cloud Compare. And I'll show you just briefly some of the Cloud Compare results. This is one scan. This was kind of my base scan because I spent a lot of time scanning the ground so I could pick up these targets with this scan. And then I just kept going successively higher. You'll see, the fender didn't fill in at all on this scan, nor did the hood or the roof. And I just kept filling in with more scans, going up higher and higher, and getting more and more of the vehicle. And then finally was able to pick up the roof. I didn't do a good job. This is literally the second vehicle scan I did. And so I didn't do a good job of really leaning out over the hood. So I never did quite fill the hood in. So, just something to learn there. So then I used, I'm brand new to Cloud Compare. It's real easy to learn how to use, and there's tons of tutorial videos, including Eugene's and other people's. So then I ended up with this and the Faro scans, and just straight up, you can see that there's really good agreement. If you just kind of, if I turn these on and off, you just kind of watch the targets, the ground control targets. They don't move hardly at all. You're picking up slightly different pieces of them, but the center points don't move at all. So one thing that I noticed, I was really surprised about, so that, Recon-3D didn't do a great job on the big featureless, panels, which is really no surprise. The Faro did pretty good. The Faro did a pretty good job of those. But what I was really surprised at is Recon-3D did a really quite a fantastic job with the chrome, which Faro doesn't do, doesn't do very well at all. See if I can get this a little bit better. You just watch this stuff kind of fill in as I turn on the Recon-3D model. The chrome and the license plate really filled in. Maybe that's because I got down lower than I did with the scanner, but I was really quite impressed with that. So then after that, I took out the ground so that I was really doing a comparison of just the vehicle. So now I've cleaned up the ground. I cleaned up some of the other points. And then I watched Eugene's video on cloud to cloud comparison. So if I turn off the Faro and I select this guy and I go to the scalar field here, I did the cloud to cloud comparison. And you can see the results are really, I thought they were really pretty good. In the areas, as from an accident reconstruction standpoint, the areas that I'd really be interested in would be to be able to do a crush measurement, or take vehicle dimensions. And you could easily get a wheelbase off of this. All of the blue is just a few millimeters. When you're starting to get green, you're starting to get into, 8, 9, 10 millimeters. So all of this blue stuff is 5 millimeters or so to the Faro cloud. And the places that really aren't very good are in the wheel wells where I don't care, in the places where I didn't get any data from the Faro scanner. Couple of places where you can see that Recon-3D doesn't do a good job, and I knew this going in, but you could see, as you get with most photogrammetry, you get these kind of bulbous features on the big, broad body panels. But quite honestly, for what I do, I don't think I really care about that. So I really quite impressed with those results. A summary of the histogram, that kind of what Eugene was showing. You got 50% of the points are within about 6 millimeters, 71% of the points up to about 10. I did one more just to capture what 90% is up to about 20 millimeters. But like I said, most of that stuff is that far out. I wouldn't really be all that concerned about. One thing that I was really impressed with was I went back. So we moved the pickup out of the way. We took the 6 measurements, the 4 sides of the rectangle and the 2 diagonals, took those measurements with help of a colleague to the nearest, 16th of an inch with a tape measure. And then I compared that to what I could do using Cloud Compare to pick points, just like Eugene was showing you. So I'm using, like I said, those targets aren't the best targets because they're black and they're white and they're shiny. They didn't return real well. But I was able to get pretty close to the center. But you can see, Recon-3D on those 6 measurements to those targets compared to my tape measure really quite favorably, less than 1/8 of an inch. And honestly, when I went in and did it, I opened the E57, the Faro E57, and did the same measurements. And I got really identical results. So from that standpoint, if you're not talking about big featureless body panels, Recon-3D could do every bit as good as the Faro as far as I'm concerned. And then there's obviously some GPS data out here as well, was actually quite good. So just my takeaways, I won't go through each one of these. You can read them watch the video and read them. But I thought that, at some point, is this going to replace my Faro? Not anytime soon. I'm going to run them side by side for a while. But when I'm a small shop, I've got one scanner. And if I need to scan in 2 places at one time, I would certainly, at some point, I will certainly consider taking my iPhone to the smaller vehicle and doing that instead of, trying to schedule the Faro on a different day, to alleviate that concept. And I think I'll say, right now, I obviously haven't taken crush measurements and done that comparison yet, but I'd say that these results to me suggest that this is going to be sufficiently accurate for doing, crush measurements, or what I do is, using my Faro point clouds to align vehicles at impact to show people how they came together and how those things match up. And this is going to work perfectly well for that. That's basically it.
That's excellent. Yeah. Thanks so much. That's great information, guy. I really appreciate it.
Thanks for the opportunity.